Let's talk about effective interest rates or effective rates of return. The effective rate depends on 1, the rate, and 2, the compounding frequency. This is the general formula for effective rates. The effective rate equals 1 plus the nominal rate in decimal form divided by the frequency of compounding, that taken to the power of the frequency, and then subtract 1. So, if the rate were 9%, and if it were compounding monthly, then you would take 9%, but in decimal form, 0.09, divided by 12. You would add 1 to that. You would take that sum to the 12th power, and then you would subtract 1, and you get 9.3807. Now, one thing that you might want to consider is that the more frequent the compounding, the higher is the effective rate. We'll go through a couple of examples in that after we go through the sample calculation using your calculator. So let's clear. We didn't have to clear time value of money. It's not a time value of money question. I'm already at 4 decimal places, so there's no need for me to go back through that. Now, note that most of us, well, all of us, learn to go from left to right on the page. But in this problem, we're actually going to start in the middle, then go to the left, and then go to the right. So here's how we would go about doing that. 0.09 is the rate, 0.09, divided by 12 equals plus 1 equals, now we have to take this to the 12th power. So y to the x, 12 equals, and then we need to subtract 1 from that, minus 1 equals, and if we want to put this in our calculator, it doesn't like decimals. It wants you to put it in percentage form, so we're going to say times 100 equals. Now that might have seemed like a lot of steps, but actually if you get used to doing this, you can do it quicker and you can get rid of some of the steps. You don't have to have all these equal signs in here. So let's clear it and just try it again, and what we would say is 0.09 divided by 12 plus 1 equals y to the x, 12 equals minus 1 times 100 equals. And actually, I think I put an extra equal sign in there that I didn't really need to use. But you see how quickly you can come up with that answer. Now, you might try calculating what the rate of return, effective rate of return would be if this were quarterly. So we're going to change the 12 to a 4. So it'd be 0.09 divided by 4 plus 1, and that equals 1.0225. Y to the x, 4, because it's 4 periods, 4 equals minus 1 times 100, and that equals 9.308. Now, compare 9.308 to 9.308 to 9.380.7. So you see that the compounding monthly gets you more than compounding quarterly. So let's try semi-annually. 0.09 divided by 2 plus 1 equals y to the x, 2 equals minus 1 times 100 equals 9.20. So you see that when we have semi-annual compounding, that's even a lower rate than quarterly compounding. So we go from 9 to 9.20 to 9.31 to 9.3807. And we'll just try compounding daily. Won't go continuously, but let's try daily compounding. 0.09 divided by 365 plus 1 equals y to the x, 365 equals minus 1 times 100 equals 9.4162. So the more frequent the compounding, the higher the rate of return that you earn.